Hey everyone. For those of you who were able to join live, thank you for joining. So to give you some context, if you haven't heard about Typesense, Typesense is an open source search engine optimized for speed. And specifically, you can build what I like to call search as you type experiences, where every key press starts returning results for you immediately. We typically optimize for sub 50 millisecond searches. And one of the features that we launched in v0.20 is what we call Geosearch. So the ability to search for locations on a map and say, get me all places, for example, within this bounded box, or with this point of center and within this radius. So that's what we call Geosearch. And today I've been meaning to build a demo to show how to build Geosearch experiences with Typesense. And I figured I'd use this opportunity to do that and share how to do that as well. And eventually I'm hoping I'll publish this as one of the showcase apps that we have, along with the other ones that we already have. Cool. So with that, let's jump right in. So I'm going to start from scratch and show you how to get this going. Okay, so I'm going to first go to the Typesense docs. Here, I'm essentially going to be following the search UI components, because we're essentially building a search UI. I'm going to start off with exactly what it says here. And essentially, this is a starter app or an app generator that gives you like a template to generate instant search apps. Now, if you're not familiar with instant search is a library. It's right here. So Instant Search JS is a library that is open sourced by Algolia, and it provides UI components to help build search interfaces. So for example, here's the widget showcase that they have. So you can add breadcrumbs, statistics, that was the actual search bar. You can add what they call refinement lists, that really filters, and then some widgets to render the results, ratings. So they have a couple of different types of widgets that you could quickly use to build a search interface. So one of the widgets, turns out, is, I don't know if they have a showcase for this. Oh, they do. Okay, so one of the widgets they offer is a Geosearch widget. So what we'll essentially be doing is using the Instant Search JS library to render the UI, but then we will send all the queries to Typesense, and where we'll be indexing the geo dataset. And then only for the UI, we'll be using the Instant Search JS library. And there's an adapter that we built for Typesense. We call it the Typesense Instant Search adapter, where all you have to do is add a couple of lines of code, and it'll start sending the queries to Typesense. So we're essentially getting Instant Search to use the custom search client that we have for Typesense. So that's an overview. So what we're first going to do is this app generator is going to generate a skeleton for us, like a scaffold that we will then edit based on that. So create, let's call this Typesense Geosearch demo. It's going to take a bit. In the meantime, let me show you how the dataset looks like. Let's see. This demo, let's create that. Okay, I haven't yet created it. Okay, right, that's this. So this particular data set, it's an Airbnb listings data set, which was captured by some site. If you Google for just Airbnb open data, you'll find that. Here's how here's how the data set looks like. So I'm just gonna get the first line. So it's a CSV file. So the first line shows the header. So this is what the CSV file looks like. So it's got listing URL, a whole bunch of things, host name, picture, images, availability, reviews. I think there was also property type, minimum, maximum nights. Yeah, property type. And there's also lat long, which is what we'll use in this Geosearch experience. The neighborhood, and then it also had amenities somewhere in there. And then here's an actual listing. So given that this is in a CSV file, one of the first things that we'll do is we'll convert this into a JSON-L file or JSON lines format, so that then we can import it into TypeSense. So we'll get back to that, but that's the data set that we'll be using. So let's go back to the application generator. So it's asking us for the name of the application. So let's leave it at that. We're going to use the vanilla instant search JS. There's also React and Vue versions of it, but we're going to use the vanilla one. We're going to use the latest version. All of these, you could just leave it same as is. I'm going to say no attributes. Let's leave it to type. All right, those are just placeholder values. We'll be editing them anyway. So let's wait for it to install all the dependencies. All right, in the meantime, what we could do is we could start the Typesense server. So I'm going back into the docs. I'm going to use Docker for this demo. So you could use Typesense Cloud to run Typesense, or you could also self-host it, or you could run it on your local machine. So I'm going to use, in this case, I'm going to use the Docker. Where is it? There we go. So Docker. It's actually Docker. This is the full command. So essentially, we're running it and binding the port 8108 from inside the Docker container to the one in the host machine. And I'm going to use this as the data directory, or mounting this volume as the data directory for Typesense to use over here. And I'm going to start it with an API key, just a dummy API key for now. So let's do that. And then create the directory. And then Docker container. Okay, that's going to take a while. All right, so we've got the app generated. Now let's quickly take a look at the source code here. I'm opening up my IDE. That's Docker. Oops. Sorry, wrong. It's just going to consume a lot of memory with my screen share here. All right, so I was just trying to open that in the web storm here. All right, and we have, let's look at the code that was generated. So that's the source file app. So essentially we have instant search. We'll be replacing this. By default, it uses the Algolia search client. We'll be replacing that with the Typesense search client shortly, but essentially it has a bunch of widgets and then a set of hits and some configuration, and we'll see what that is, and then some pagination. So by default, it's configured to communicate with Algolia. So let's just start this. Okay, let's just do it here. Okay. All right, so it is blank, and I just noticed this today that by default, the app generator throws this error. So what we'll have to do is edit this out. Let's remove this damn widgets here. I think we just need to mount like an element here. So okay, so this data by default it's hitting in Algolia index, and that's what the app generator, because it's built by Algolia. So it by default hits one of their indices, and what we're going to do is now make this app dock to Typesense, and then also build a Geosearch UI on top of it. All right, so our scaffolding is ready now. Let's get our data ready. So let's start Typesense here, and Typesense is up and running. Now let's go back to our data set here. So the idea is to, so let's go back to this. The idea is to first select the subset of fields that we actually need for this demo, and then convert it into JSON-L, like we're saying. So I'm going to write a quick script to do that first. So let's okay, right. So, all right, so cool. So the first thing to do is, just so you don't have to watch me like tediously type out code, I'm gonna quickly copy paste this from the my playground that I was trying out earlier. So we're gonna quickly first import a couple of things. So what's that? So we're essentially using this library called CSV to JSON to convert the CSV to JSON. So this is a library where you give it a bunch of CSV files or strings, it'll convert it into JSON, and then we'll write it out into a file. And the reason we're breaking this out into two separate things, where we're first taking the CSV file, converting it into JSON-L, and then we're going to index it in bulk into Typesense, is because bulk indexing in Typesense is much more performant than having to index every single line one by one. So that's the reason we're converting everything in one shot and then bulk inserting it into Typesense as a separate process. So we're going to get that. Let's move the data file here. We'll move it into Geosearch demo. Let's create a shortcut. Let's say data file, this there. Let's exclude this so Webstorm doesn't start indexing it. All right, so I'm going to define a data directory here. Just leave it as this, and then I'm gonna write a quick function. So I want to use the async await keyword. So I'm going to put this inside an async function. So the first thing we're going to do is open a file handle for the output file. So I'm going to call this transform JSON-L, essentially opening a file handle, and then I am going to read the file. Let's take a shortcut here. Editor, probably not resolved. Let's just Okay, and then so we have the file handle. That actually reads the entire directory. We don't want that to have a different. So essentially, we're gonna say call this CSV to JSON, and then from this file, and this is actually the file grab. So we're just saying parse this from this CSV file, and we're going to read it line by line so that we also need to select a subset of fields from the CSV file. So we need to transform it a little bit. So we're saying that for every line, this method gets called, and this is the actual CSV record. So let's just console.log this for now and run it, and I'll show you how this looks. Let's call this transform data node. Let's now quickly run this. Yarn transform data. Actually run the oh, I didn't add the dependency, so let's add that. Yes. Probably added that as a dependency. Cool. So essentially printing out every record. So if you notice, the CSV file was converted into a JSON. So here's how the rough JSON looks like. And now we could index all of this as is into Typesense, but I'm going to just pick the ones that I need for this particular demo, like things like lat long, property type, room type, beds and amenities. This looks like an interesting field for filtering and faceting, price, so that people can filter by price, and maybe reviews, but let's see if we have time to get to that. So that's how the data looks like. Now, the idea is to select just a subset of fields. So I'm going to say, here's the list of fields that I want to pick. So I'm going to pick ID, picture, URL, the name of the place, the host name, the neighborhood, property type, etc. And this essentially selects from this particular record. It selects a subset of keys and puts it back into a hash object here. So, and then by default, by default, there were some data type mismatches here, so I'm going to convert the geo coordinates into float types. By default, it was sent as a string. The library passed it as a string, so I'll parse them as floats. The amenities were just a comma separated list, so I'm going to parse that into JSON. Parse that into an actual array. And then I think accommodates was a string, again, a whole bunch of just type conversions from the CSV file. Same thing with the number of beds, and then same thing with the price was a string, and I'm going to convert that into float, and then also remove. Actually, sorry, the price was a string with a dollar symbol, so I'm removing that and converting it to a float, so we can do numerical operations on it. And yeah, okay, let's leave out the others for now. So that's pretty much it. And then finally, let's look at how this looks like. So I'm going to run the file again. Okay, so essentially extracted a subset of the fields. So it's ID, picture, URL, name, host name, accommodates, beds, and amenities. So for every record, and price and coordinates now is a float. Earlier it was a string type. So essentially we're cleansing the data so we could then index it into Typesense. And then I'm gonna write this into a file handle. So I'm just JSON stringifying every record and then appending it with a new line. That's what the JSON-L file format is. It's every line has one JSON object, and that's pretty much it. So let's now run this. I guess I didn't print any console.log, but if you notice, the transformation itself took 7 seconds. So let's look at the data. Oh, I put it one directory higher, so it showed up over here. Okay. Cool. So let's see how that file looks like. Data transform data set, just to format it. So that's how the file looks like. Or if we want to see it without GQ, say let's look at the first 2 lines. So it's essentially JSON-L. So there's the first object, and then there's the second object. So now we have the file, the data in a format that we can bulk import into Typesense. Now, of course, you could do it in one shot as well. I was actually testing this with a much larger data set with 1 million records. At that scale, you typically want to make sure that the transformation itself isn't taking such a long time that the number of batches that are sent to Typesense then end up being much smaller. So if for large data sets, it's good to do all the transformations separately and then bulk insert it in one shot. So, all right, so that's the transformation. Now let's create a script to index the data. And now we need to add, we need the Typesense library because we're going to make calls to Typesense. Do that. So we're gonna read this line by line. So again, I'm gonna just make sure that you don't have to watch me tediously typing. So again, we're requiring a bunch of stuff. This is the Typesense library. This particular library helps read files line by line. Read line dependency. A couple of and I'm gonna, so again, that example I was looking at, let's see how many lines are in this particular it's only 32,000. So I mean, I could insert the entire thing in one batch, but I want to show typically in larger data sets how you'd approach this. So you probably want a .env file. Is there one here? No, that doesn't generate one for you. Let's create a .env. And here, Typesense host, port protocol, the admin key and the API key. Now let's add .env, because that's what's going to help parse the file, the configuration file. just so we don't have to type up the configuration times. Let's initialize the client. So all we're doing is calling typesense.client and then saying nodes. Here's the node to use. Here's the node to connect to. Here's the API key. And since this is an import operation, I'm saying give it at least, well, I probably don't need 20 minutes in this case. This is smaller. And then I'm going to call this function. Let's call it, because I want to use async await inside the top level. All right, so what we're going to do is create this thing called an alias. And what an alias does is, especially if you're reindexing multiple times, it's good to create an alias. It's like a symlink where you can say this particular symlink points to this particular collection. So typically you'd create like a timestamped collection for the actual collection name, and then you would point an alias at that particular collection. So what we're going to do is create an alias here. Let's also do this. Actually, not create alias, but let's create a brand new collection first. So let me check this part out. So let's typesense.collections.create. So we want the name to be the collection name. So if you notice, I'm using the alias name, and then inside the alias name, I'm using a timestamp, using the current timestamp as the actual collection name. And then for the fields, I'm gonna say fields is an array. Field name, the first field name is name, followed, and it's a type of string. This documentation, by the way, is in the collection. I'm using a predefined schema, but you can just as easily use a auto schema detection. So I'm essentially defining what type of field it is and whether it's a facet or not. So name, and then neighborhood. So for this, I'm essentially, if you look at essentially creating a field for every one of these items that I actually want to search or filter on. Okay, for this demo, I'm going to simplify it a little bit. Let's just do, we're not going to search by name. Instead, let's just do filtering or a browsing experience. So let's say you want to search by property type, whether it's a private room or an entire apartment, and then how many beds it has. Let's do that. And then let's do all the amenities. That's a good one to filter on. Of course, we want to filter by price, and we want to sort by, or of course, we want to do geosearching here. So adding that to the schema. Now you can add other fields. If you notice, there are other fields in the actual document, but I don't have to include all of them here, because I only want to, anything that I want to search or filter a facet by, those are the only fields you want to include here. Everything else will just get stored on disk and then get returned if that particular object is a hit or a match for a particular search query. So that's the schema, and that would create the collection. Now what I'm going to do is read the JSON-L file that we created over here, line by line, batch it up into batches of client batch size, and then do an import call into Typesense. So this is how that particular library works. I'm creating a read stream, and then I'm going to keep track of the current line here, and this is the variable that I'm going to be using to accumulate the JSON-L string, and I'm going to do a for await of async operation, and let's keep track of the variables. And I'm just accumulating, like appending to the records. And if the current line number reaches the batch size, if that's a multiple of the batch size, which is what mod 0 does, then write whatever you've accumulated into the records string, which is a collection of JSON-L strings, into Typesense. So let's do that. So results with Typesense dot collections. We want to write it into the collection dot documents import, and we want to import all the records here. And then we want to look at the results. So because I'm passing in a JSON-L string, the result will also be a string, so I need to parse that. So I'm splitting the JSON-L response by new line, and then parsing the individual objects. And then I'm going to say, well, if there's any failures, filter out all the failures. That's the response if there's a failure. See failure false. And if there are any errors, then console.log the console.error the errors. And then finally, let's set the records as records with the accumulator as an empty string, so that the next time it keeps accumulating the next batch of records. Now let's quickly add some console log statements here, so that we know as it's progressing. Okay, now the last batch will not get, will still be in the records variable. So we need to, after the for loop ends, we have to do one last check where if records is not empty, then insert that final list of records into Typesense. Now that will get the data into Typesense. Now let's update the alias, or let's first get to see if there's an existing alias. So we do. So we're trying to see, is there an existing collection? If there is, then we want to delete that collection after we repoint the alias into this particular collection that we're creating. So I'm gonna do. We don't want it. It throws an exception, and we don't want it to error out. So we've gotten the old collection name. Then we're gonna now actually create the alias. So with Typesense aliases dot insert. This is the alias name. In this case, it's Airbnb listings that we defined up top here. We're gonna point Airbnb underscore listings to this particular collection name, which was the timestamp collection name that we just created over here. So we've created the alias. And then finally, we can say, probably need to catch. Catch. You can say if the old collection exists, then we're going to delete the old collection. So we're getting the old collection name by checking if there's an alias from that already exists that's pointing to the old collection. We probably want to console here, and that's pretty much it. Let's hope this works. Just crack it somewhere. Oh. Yeah, okay. obviously improves for that. Cool. Okay, I think we're all set. So let's add this to package.json here. So in general, I would say half the battle in building a good search experience is getting the data formatted in a way that's good enough to search on. So which is why this probably took most of our time. Building the actual UI piece is actually easier, given that we have like UI components that Instant Search gives us. So let's call this index data. Call that script. Run this. Yeah. Right. Okay, so that's adding all the records. So there are about 30,000 records. I could have probably increased the batch size. I was expecting this to go even more faster. Okay, so while that's going, which will be done shortly, let's get our app ready here. So we're gonna first install the Instant Search adapter. Yeah, we can make note of that. It succeeded. It took about 46 seconds for that. Let's let's install the Instant Search adapter here. So that's the adapter that's going to get Instant Search to work with Typesense. So far we've got the source CSV data, and then we transformed it using the script, and then we into a JSON file, and then we indexed it into Typesense, and now that data is sitting in Typesense. So if you want to look at it, I can say list all collections. Let's quickly do that. So that's the collection that we just created. So Airbnb listings. So if you notice, that's the timestamp. We have about 32,000 documents, and these are the fields that we just added in the schema. And then we'll be able, basically, if you want to search through it in the command line, you could do that with the documents search endpoint. So the data is basically ready in Typesense. Now we have to build a UI on top of it. So now that's the next piece. So building the UI, let's up here. And so the first thing we're going to do is add the Instant Search adapter here. And then, so we're essentially going to have to change this into this. So like this piece. Set the let's read from the .env file here. I think already done for us by Parcel. So Parcel is the application bundler that we're using here. So Parcel automatically reads the .env file, so we probably don't do that. So we don't have to load .env separately. So process.env. So this is directly coming from the .env file here. So we're reading the nodes and then setting the search client. And in this case, we call this Airbnb listings. Notice that I'm using the index name, sorry, the alias name, not the actual collection name, because the alias points to the collection. So we can clear that. And then now it's a matter of configuring the widgets. So let's quickly put down there. That's simple for now. I'll have the styling later. All this map. Okay. And then we'll reference that in this widget here. So instance search. So instance search, and then instance search dot widgets dot geosearch. Let's look at the documentation for this real quick. Geosearch, instance search. So we need to pass in the container, which in this case was Google reference. So we're going to be using Google Maps to render the map, so we have to take care of that, but I'll come back to that in a sec. So probably want to get an API key from the Google Cloud console, and you should be able to find articles on how to do that online. And once you have the API key, you'll get a script to load Google Docs first. Sorry, not Google Docs, Google Maps first. So essentially, we're loading the Google Maps API with this API key that I created. And also, when you create the API key, make sure it's restricted to just the domains that will be accessing that, because I think Google Maps API is now a charged service, so you don't want that API key to be used elsewhere. Right, so we've loaded Google Maps here. Let's see if that renders anything. Let's see. Interesting. I guess it's not reading this somehow. Oh, you know why? That's because this needs to be in this. So this server block is like passed to Typesense JS under the hood directly. So it should say something else. Google reference option. Oh, yeah. So the way Google Maps is I wasted a lot of time when I was trying to figure this out the first time. But essentially, to get the Google Maps API to work, you need to have this init map function on the window object, and then you add all of this inside this, and then you'll see basically it's a callback that the Google Maps API calls, which is what we've mentioned here. After the script loads, after Google Maps loads, we're saying call this function called init map, so it has to be available in the window object, and at that time window.google will be available. So now it is loading, but it is course there. Course. Nope. Okay. All right. We get a 200 from Typesense. Now we need to set the width and height for that map for it to render properly. So In the interest of time, I'm going to quickly copy paste some CSS here so that it looks semi-decent as we are building it. Then I'm going to also use Bootstrap here. That's Bootstrap, and then yeah, this particular version of Bootstrap requires using query 3.6. This popper. Okay, so that's there. Let's use for some customizations. Essentially, I'm customizing a whole bunch of variables here, the color scheme and some margins and things like that. Let's get rid of that. And then some more CSS here. So let's take a sec. Okay. Okay, let's recompile now. So I had set a width and a height there, so it should render something right after it builds everything. No, I don't think that's new because I think parcel comes with table runtime. Okay, that shouldn't take too long. Oops. Yeah, there's a bunch of deprecation warnings. We could do like this separately, but it's happening there. Oh. Let's see if that's okay. What that does. All right, so we have a map, but pins are not loading. Let's see what query is being sent here. Okay, so at least the Typesense server is returning responses. So, oh, that's right. I don't think I actually entered what to do with the actual map. Okay, let's keep going. I mapped the pins, I believe. Oh, I don't think this CSS. Okay, it's still not loading. Okay, let's see. So we continue. Just missing. Okay. All right, back to index.html. Now let's quickly. So what we want to show is the map on one side and a set of filters on the other side. So let's do the. So this is the. And that's for. In that we want to show. So for 8 columns, we want to show the map. And then the rest of the columns want to show the Geosearch UI for the filters, etc. Make this look really nice. Let's pull some padding. And then let's add some. Actually, before that, I'm still wondering why the map is not rendering. Then the filters will be useful. The order of that should number this types. Okay, there's some more stuff that the built-in marker. I think I can customize that a bit. That's another option in the Geosearch here, where the built-in marker, you can basically customize it to, I wanted to show a pop-up with the actual images here. And then let's also make sure that we don't want the whole map to show up. So we're gonna first have, we're gonna say only show within this bounding box is essentially like the Los Angeles area. That should zoom in a little bit. Oh, that's why it's not loading. Okay, let me see. So by default, Algolia uses the field called _geolocation, but in Typesense you can customize the name of the field, and we called it. Remember, we called it coordinates here. So we need to tell the adapter that, hey, use the coordinates field when talking to Typesense. So that was called. The geolocation field here. Server. show the coordinates, and yep, that's what we want to do. I think the pins should render now. There we go. Okay, that was the issue. All right, so we have some pins rendering, and so far, okay, let's go. Without this particular built-in marker, if I had clicked on any of these, it basically won't do anything, but I want a pop-up to show up. So for the pop-up to show up, essentially I'm customizing the built-in marker to say, if I click on it, then show an info window, which is what Google Maps calls it. And I want to show the neighborhood, the picture of the item, of the result, and I want to open the window. So that's what that code does. So now refresh, should see the image load. I mean, it's not, this still got left to do on the styling part, but this is coming from Typesense. So if you, all of this is coming from Typesense. So if you notice, we're not yet doing any text-based search, and as I move the map, it starts searching for more results. So this is what I meant by, I think I mentioned it in the announcement, but I call this move as you type, kind of like search as you type. This is move, move as you, search as you move. Yeah, search as you move is what I'd call this. And this particular data set only had listings in Los Angeles, which is why only those areas are being populated. So, if you zoom in, we'll start seeing way more results here. Okay, so let's fill out this empty area on the right here real quick. And again, this is probably the easiest part of this whole thing. We're gonna add a widget there. Refinement list. The attribute we want to use is what do we call it? Let's say amenities. Oops. Amenities, I think. Amenities, and then I want to mount it on this thing called the DOM. Let's go back to the DOM. And then in the UI, let's add a maybe keys. Yeah, there we go. And we have all the amenities showing up. So if I want to filter by only things that have a hair dryer, that's that. I want things with hangers. That's interesting. And then long-term stay is allowed. Let's look at this. So it should say long-term stays allowed somewhere. Yep, right there. Long-term stays allowed. Now let's look at price. Now price is important. Important filter here. So let's say price maybe up. And let's go back to widgets. I'm gonna add another widget. Let's mirror this. And then I think it's called a numeric. Oh, sorry, it's called a range slider. Range slider. Say price and mount it on the price. That should pretty much. By the way, by default, I don't think this UI shows up very well, and that's this. There's some CSS that I had to custom handwrite to get that thing to show up. So there's something that's there's a little bit of a culture there. So let's look at most expensive. Here it is. Let's see how they look. Sky phone price. That looks pretty good. I want something with essentials. So that filters guess I put this things out. Okay. Then let's probably add, what else is there? We can add, property type. That's an interesting one. H5 property type div. And go back to app. And this is still a refinement list. Let's call it property type. And there we go. So let's look for entire bungalow. That's interesting. And then we want the lowest of the lowest here. So interesting. Some of them are categorized as entire bungalow. Anyway, so there's that. And then let's say we also want to add a beds. Let's first add it to the number of beds available in the property. Beds. Go back here, and this time let's use what's called a range input. So it lets you enter the actual count, the min and the max values. And there we go. There's beds again. So I'm going to apply CSS to this shortly, but so there's something with 26 beds. I'm curious to see that. That's the minimum to 25. They're renting out an entire dorm room at USC with 25 beds. Too interesting. All right, so that's those are the filters. Now let's quickly add some styling to this so it looks a little nicer. And that's the nice thing about Instant Search is you can add styling with customizing the classes. So I'm just gonna copy paste that here. List. So for the navigate list. Options. I'm going to allow it to be searchable. That's one thing that Typesense can do is you can allow facets to be searchable as well. So let's look at this. It should show up much better. So those are all the classes that I'm adding classes to each of the elements, and the documentation has every widget has this thing called Css Classes, and you can apply basically anything. And these are I'm using Bootstrap classes and applying them to the Instant Search widgets. So this is what controls this particular. When I set searchable true, that made this particular field available. Now I can search for bathtub maybe, or backyard, etc., and then select that. All right, and so pretty much the same story for property type as well. Make it a little nicer here. Type. So probably need to add a little padding there, but or margin there, so that looks nice. And then do the range input. Let's add some more styles. Yeah, probably want to add a little bit of margin there. Anyway, so that's pretty much it. Let's see if I missed anything. Let's say if you want to also show the number of results returned, there's a widget called stats. Let's add that in .widget.stats. Maintainer stats, and then let's add that with DOM right on top. And that should show us this. Widgets. Well, there we go. Okay, so okay, there we go. So many results found. Then, as I keep scrolling, it should show you how many results are found right there. And then as I keep adding stuff, so my computer with all the screen sharing is causing, I think, the Typesense local Typesense server itself to run a little bit slow. But that's pretty much it. So from scratch. So what I'm going to do is I need to clean this up a little bit more and add some more documentation around how to do different things. And I will push this to GitHub and also publish it live under a domain, under a Typesense subdomain, and along with the source code. So we should be able to just clone this and run it locally as well, and play around with Geosearch and Typesense yourself. All right, so that's pretty much it. So like I said, this will be available as a recording. Feel free to jump into our Slack channel if you have any additional questions on this, or ask questions in the Q&A section as well at any time, even asynchronously. And I think I get notifications, or ask in our Slack channel. So happy to answer any questions. Yeah, thank you for staying up.